before we leave the topic of binomial distributions, it's important to know how to calculate the expected value, the standard deviation variance of a binomial distribution. So if we have a key couple points, we know it's a binomial distribution, you automatically know the expected value, the average, and the variance and the standard deviation. So if we know it's a binomial random variable, we know that we're choosing, what was it? 3 males out of 5. We know that n is 5. We know that that we're looking at 3. We know the probability. Well, expected value is simply n times p. Probability times the number of trials. The variance, sigma squared, is n times p times q, where q is simply the probability of the non-success, the probability of the failure, which is 1 minus p. So n times p times 1 minus p is how it is instead of q. And the standard deviation then is just the square root of that. So in our example where we were looking at tossing a coin, we already found the expected value was 1.5. Well, if we have 3 coin tosses, which is what we had in our demo, is we toss the coin 3 times each round, there's a 50% chance of it being heads, right? Because it can only be heads or tails. They're equally weighted. Then the expected value is 1.5, n times p, and we can get that then this way with n times p much quicker than having to go through what we did in the previous video, which was we found the probability of each outcome, we multiplied it times each outcome to find that expected value through that weighted average. So we can just do n times p. With the variance, remember it's n times p times 1 minus p. And so we before found the variance was 0.75. You can see that here through the formula as well, because if we have 3 coin tosses, the probability of heads is 0.5. The probability of tails is 1 minus 0.5. You get that 0.75. And the square root of that is 0.866. So these are the same results we found earlier with our example. But if we know that something is a binomial, then you can very quickly find the expected value and the variance without having to go through all the different possible outcomes. Let's look at an example. An insurance representative has appointments with 4 prospective clients tomorrow. From past experience, she knows the probability of making a sale on any appointment is 0.2. So we know that P equals 0.2. And that we have 4 prospective clients. So the random variable here is going to be a sale, and either a sale is made or is not made. So it's a binomial random variable because there are 2 possible outcomes, sale or no sale. And if we're doing this 4 times with 4 different clients, each time there's a 20% chance of sale. That probability doesn't change. Each sale is separate and independent of each other, and so we could find the probability that x equals 3. On average, how many expected policies will the insurance representative sell? Well, that's going to be n times p, and so if there's 4 prospective clients, the probability is 20%. 4 times 0.2 gives us the expected value. How much variability is there? Remember, variability, sigma squared, is equal to n times p times 1 minus p. And so to find that calculation, we have the 4 meetings with clients times the probability 0.2 times 0.8. 1 minus 0.2. So we can find our variability in our example. So what do we find? We find 4 times 0.2 is 0.8. So how many policies will the insurance representative sell? If there's 4 meetings with clients, they won't quite have 1 sale out of the 4. So you got to have more than 4 clients in a day if you want at least 1 sale. The variability in that, 4 times 0.2 times 0.8 is 0.64. So on average, we're going to take a square root of that to find the standard deviation. Remember, standard deviation is sigma. So it's the square root of that 0.64. And you get 0.8. Okay. What is the probability she will sell a policy to exactly 3 out of 4 prospective clients? So here we're using our binomial distribution. We could use the full-blown formula, right? And choose X. And yeah, even I don't remember all that stuff off the top of my head. Scroll back. All the way. P to the X, Q to the N minus X. And the reason I don't ever remember that off the top of my head is because you just stick it into Excel or whatever your stats is. So let's find the probability that X equals 3. If we're doing it on a table, then we would go to our table, binomial table, and we would go where N equals 4, and our probability is 20%, and we're looking for the probability that X is equal to 3. And we would get 2.6%. All right, let's do that in Excel. Equals binom distribution, and we have the number we're looking for is 3, trials is 4, probability is 0.2. Comma equals false because we're doing probability mass function. And we get that same 0.0256. So you can find the probability that you're going to have 3 policies sold out of 4 prospective clients when the probability of a sale is 20%. Some additional characteristics of binomial distributions, just as we're wrapping up our discussion of binomial distributions, is that if the number of trials N remains the same, but the probabilities increase, then the shape of the distribution starts to change. As the probability approaches 0.5, then that distribution starts to get more symmetric. So what you can see here in this visual is that we go from here from a probability of 0.5%, 10%, 20%, 50%. And so at 50%, we get a symmetrical distribution. And as we get smaller or larger than that, we start to get that skewed distribution. If the probabilities P remain the same, but the number of trials increase, then the shape of the distribution becomes more and more symmetric. So in this case, all we're doing is changing N, and you start to get closer and closer to that symmetric distribution.